can't be done in Desmos. That's something you have to know how to do. 2, since you're given the graph, you can't really do it in Desmos, so you just kind of have to guess, but I'll talk about that one. 3, because of the decimals and fractions we're going to get, it would be difficult to do in Desmos. So I'm just going to do that one algebraically. But in the future, I will let you guys choose whether you want to see it done algebraically or in Desmos. We should be practicing doing as many of these in Desmos as possible moving forward. Number 1, translate the statement 5 times the difference of the number and 3 is 17. So 5 multiplied to parentheses, pick a variable, minus 3. And then the is equals 17. So if you have anything other than that, go ahead and fix that. Remember that when you're going from words to algebraic, there's really only one right way to do it, but from algebraic to words, there's a bunch. The y-intercept of this, you can guess, there are 2, but because they're not on a integer, you can guess whatever that is, as long as it makes sense. So something between 1 and 2, 1.6 to 1.9. Any of those decimals in between there would work. You don't have to put that. You can pick a decimal, 1.6, 1.6 something, 1.7, 1.7 something, 1.8, or 8 something, 9. 1.99 might be too much, or like anything above 1.9 might be too much. For this one, anything between negative 1 point that's closer to the end, so like 1.7 to 1.9. So pick a decimal, it doesn't matter what it is, as long as it falls between that range. So when you get a graph like this and the x and y-intercept is not exact, just estimate. Question on that one. Okay. And then number 3 had a lot, so you may want to change this to the 5 spot if you didn't already. You have to find the slope of this and then find the equation. So as a refresher, our slope, we're using our y2 minus y1 over x2 minus x1. So this would give us 3/4 minus 4/5 all over 1/7 minus 1/2. And then we would need to get common denominators for everything. So we could multiply this fraction by 4, this fraction by 5, this fraction by 7, and this fraction by 2. So all of your fractions would change. So we'd have 15/20 minus 16/20 all over 2/14 minus 7/14. And then we could simplify, subtract both sets of fractions. So negative 1/20 over negative 5/14. And then that part you could do in the calculator. Either put everything in all together, or take this bottom part, flip it, and multiply it. So let's say I just multiplied. So you then for this one, I'll let you if you wanted to, or if you did this, if you put this as a fraction, as a decimal, that's fine because it's a nice short decimal. So 7/50ths or 0.14. Because when we go to put this into our equation to find the y-intercept, we get an even messier fraction. So using the decimal here would be easier. So then we would be using our point slope, using one of these ordered pairs. Use the first one. And I'm going to change both fractions to decimals and use our slope decimal. So y minus 4/5 would be 0.8. Our slope is 0.14. X minus 1/2, 0.5. And then I could solve this. And then when I add 0.8, my equation would be y equals 0.14x plus 0.7. If this were in fractions, it would be y equals 7/50ths x plus 73/100. Do we have any questions on that? This could be done in decimals, but I wouldn't recommend it because of all the different decimals. You would have to change how decimals looks in order to really do this one on decimals. Once you have finished, we are going to start our elimination notes. Read this down. Elimination method is where you add or subtract or multiply and then add or subtract to eliminate a variable. Make sure the equations are lined up. Add or subtract the equations to eliminate the variable with common coefficients. Solve the equation for the remaining variable. Substitute your answer into either equation and solve for the other variable. So step 3 and 4 are really the same as the substitution method, but step 1 and step 2 are different. There's also another kind of step in there that pertains to the last part. If there aren't common coefficients, multiply one or both equations by a number to make them common. So we'll talk about that in a minute. We're going to start with 1. So make sure the equations are lined up, which means your y's are on top of each other, the equals are on top of each other, the x's and the constants. That is the case here. Then you're looking for which variable has the same common coefficient. Which one would that be in this case? X or y? Are these numbers the same? So not x but y, because the common coefficient is 1. So once you have figured out which one has the common coefficient or similar, we're going to eliminate it. Eliminate means what? Get rid of. So we're going to get rid of the y's by either adding or subtracting. Would adding or subtracting make this 0? Eliminate them. Get rid of them.
Subtract.
Yes. So we're going to subtract both equations from each other. The top from the bottom. The bottom from the top. Y minus y would give us 0. 3x minus x would give us 2x. Now here, be careful with your negatives. 4 minus a negative 2, that would become a plus, a positive 6. From there, we would solve for x by doing what? I didn't hear what you said. We will divide, not first though.
So we subtract 6.
Subtract 6. Actually, in this case, it wouldn't really matter, but you would still have to move the 6 and divide both sides by 2. Just like with substitution, because it is a system, x isn't our end answer. We need an x and a y to make it an ordered pair. So we're going to take that negative 3 and put it into one of the equations. It does not matter which one. And find y. So I'm going to do the second one. I meant to say this. If these boxes are too small, feel free to either write on the back of the first page or grab another sheet of paper. So our y value would be what? -5. So then we would write that as an ordered pair, -3, -5. Questions on that process so far? So then in number 2,
How'd you get a -5?
-3 minus 4. In number 2, they're not set up the same, but that's okay. It doesn't have to be in y equals mx plus b. They just have to be lined up, which they are. Which variable has a common coefficient? X. So would we add or subtract these to eliminate x? Subtract. There we go. So subtract the equations. X minus x gives us 0. 4y, again, be careful with your negatives. Minus a negative becomes a plus 5y. 13 minus 3 is 10. And then from here, we can just divide. And then once you have one variable, go ahead and put it back into one of the equations, doesn't matter which one. Solve for x. I'm again going to use the second one just because. So our x value would be 5. And we would write that 5 too. questions so far? We're going to skip 3, move on to number 4. Which variable has a common or similar coefficient? X. So they don't have to be exactly the same. They can be, one can be negative, one can be positive. So if we were to eliminate our x's here, would we add or subtract? What do you think? Add. And if you're not sure, you can double check it in the calculator. If I did 4 plus a negative 4, it would eliminate. But if I did 4 minus a negative 4, it would. So if you're not sure, use your calculator, double check yourself. So I'm going to add. Also, in general, if the signs are the same, if they're both positive or both negative, subtract. If the signs are different, add. So if we add these together, we know that's going to eliminate, become 0. 9 plus 7 would give us 16y. 5 plus 11 would also give us 16. So that y is what's the value of y? And then put that back into one of your equations and solve for x. Let's say I chose the first one. Again, it doesn't matter if you chose the first or the second. You should still get the same answer either way. So if you use the second one and you still got negative 1, then that's fine. The ordered pair there would be negative 1. Okay, 1. Stop. Questions on that? Five is not lined up like it should be, so we're going to do that one. And you have a choice. You can either make the first equation look like the second, or make the second look like the first. Do we want to move the first or the second?
Second.
Okay. So if we want to change the second to look like the first, we have to move this y to the other side. And I'm going to just rewrite both so I have them right next to each other. So in this, which variable are we going to eliminate? Which one has common coefficients? Would we add or subtract to eliminate? So negative x minus 2x would be negative 3x. 3y minus 3y would be 0. And 11 minus 10 would be 1. So when we solve this, we're going to get a fraction. Sometimes that happens. Sometimes that can happen by mistake. So double check your answers. So then when you get your value, you have 3 choices now to put your values back into. The original 2, or the equation you changed it to. Any of those, it doesn't matter which one. But let's say I put this into this one, the very first one. I'm going to write it off to the side, but it's going to look a little smushed for a second. You could have chosen the other one. I just used this one to kind of get rid of the negatives. And then we could solve this by subtracting 11. Use your calculator. So as you start to see, you get not nice fractions. And when you go to solve for y, you can do one of 2 things. Divide both sides by 3 like you would normally, and you'll end up with a fraction within a fraction, which you could put in the calculator. But if you wanted to avoid that, instead of dividing, you could take the 3 and flip it and multiply by 1/3. So that you avoid that and are left with negative 32x. So your ordered pair would be negative 1/3, negative 32/9. If you were to check that algebraically, or if you got a problem like that on Delta Math and checked it on Desmos, that would be the answer. You would just have to change the decimal to a fraction. Do you have any questions about that one? Number 7 is missing in equals. It's supposed to be before the negative 10. Go ahead and put that in there. We'll hold off on doing that for now. Skip to number 9. Do we have common coefficients in number 9? No. So it means it wouldn't be no solution. You have to find or make some. You have a choice whether you want that to be x or y. It's up to you. But in this case, the easier of the two would be x, because we have to make these 2 numbers the same. We have a 1, we have a 2. We could make this the same by multiplying it by what to make it 2? 2. But we can't just multiply it to x, so we can multiply it to the entire equation. So the entire equation changes. And I'm going to write that underneath. So we have 2x plus 6y equals 12. Then everything else is the same. So to eliminate our x's, we would add or subtract. We have 0, negative 7 minus 6 is negative 13. Y, negative 1 minus 12, also negative 13. So what's our y value? Now you have 3 different choices, much like the one in number 5. Put that back into one of the equations and solve for x. I'm going to do this first original one. Solve for x, what do you get? plus 3 equals 6. And if I subtract the 3, 3. So our solution would be 3, 1. Any questions, confusions on that one? Let's look at number 10. Does that one have common coefficients? And unlike number 9, it doesn't have an x by itself either. So we have a choice. Do we want to eliminate the x's or y's? You guys choose.
X.
Okay. So if we want to eliminate x's, we have to make both of these the same number. So we have to think about a number that these both go into. That 3 and 5 both go into 15. To make these 15, I would have to multiply this by 5 and the second one by 3. Sometimes the easiest is just multiplying them by each other. Sometimes that's too big of a number, but it depends. So we'll have two new equations. I'll rewrite them. 15x plus 15y equals 45. And 15x plus 12y equals 30. Now that we have common coefficients, would we add or subtract to eliminate? Subtract. So we have 0 plus 3y equals 15. What's our y value? 5. And now you have 4 choices to put your y value back in to find x. Pick one of those and start to solve. What did we get for our x value? You didn't use my equation. That's okay, as long as you use one of them.
-2.
And then that order pair will be -2. Do we have any questions in general or specifically on how elimination works with adding and subtracting or with multiplying and adding and subtracting? We're going to do one special case, and then any you guys want to see, and then you'll have time to practice. So let's go back to number 7. We do have common coefficients here. Do we want to eliminate x or y? You guys choose. Okay, so if we're eliminating x, will we add or subtract?
Subtract.
Well, what happens when we subtract? minus negative 13, that will be a plus. So your variables cancel, you get 0 equals 3, which is what had the solution. Do you have any questions? Or any others we want to see do go over, have questions about? I will say for the special case, it'll either be like this where they're already common coefficients and then they eliminate right away, or I think 14 is a special case, or I don't remember off the top of my head, where you may have to multiply one or both, get them to be the same, and then they eliminate. As in
Numbers.
do we want to eliminate x's or y's? Okay. In this case, it doesn't matter. You have the same coefficient for y, you have similar coefficients for x, but either or doesn't matter. So let's say we eliminate y, would we add or subtract? Would we add or subtract for that one? So then we have 0 equals negative x minus x is negative 2x. 4 minus a negative 4, that would be 4 plus. And then we would solve this just as we did the very first one. Get rid of 8. And divide both sides by negative 2. Then you could put that back in. I would say probably the second one. Zero can be part of your solution. That doesn't make it no solution or infinitely many. So if you get 0, don't freak out. Unless your variables have canceled, then it can become no solution infinitely many. I'm going to give you guys time to practice. You'll be working on one of the following things. You'll be working on this. There are the rest of these practice problems as well as the practice problems on the back. The delta math on this that is due tomorrow. Or if you did not do the delta math from Friday, the solving systems by graphing and by substitution, you can be working on that. If you need to finish a test or work on this paperwork, that will happen after the delta math